momentum is the measure of inertia of motion. More the momentum, longer the object wants to keep moving, okay, or harder it is to stop the object. So momentum is basically, it tells us how hard an object is to stop. So bigger the object, harder it to stop. That's the first thing. Also, faster the object is moving, harder it is to stop. Okay, so we have two things. Momentum depends on how big the object is, how massive the object is. It also depends on how fast the object is moving. So momentum is the product of mass times velocity, because momentum depends on mass and velocity. So it's the product of mass and velocity. And give me a second. And the mass is measured in kilogram. Velocity is measured in meters per second. So that means the unit of momentum is kilogram meters per second. Okay. Momentum is the product of mass and velocity is a vector quantity. Vector quantity means it has magnitude as well as direction. That means momentum is also a vector quantity. That means momentum has both magnitude and direction. Magnitude means value, as well as we know which way the object is moving. Okay. Now, if we don't care about the direction, sometimes we don't need to worry about the direction, we only need to know the magnitude. Okay. In that case, we can just call momentum as the product of mass and speed. Okay. The actual definition of momentum is the product of mass and velocity, mass times velocity. That's the actual definition. But when the direction is unimportant, when we don't need to worry about the direction, then we just write it mass times speed. And speed and velocity are basically same thing, except speed does not have the information about direction. Okay, so this one doesn't have no information about the direction. So let's look at the first question on the assignment 11.2. So on the question, you are given momentum of an object, and you are asked to find the speed of the object. So we have momentum. Momentum is denoted by letter P. P is given by P is given, so 12 kilogram meters per second, and the mass is also given. Mass is 4 kilogram, and we want to find the speed. Okay, and whenever you see the word speed, that means direction is not important. We are just trying to find the value. So we know the formula for momentum. M is P is m times v, and we want to find v. So we can rearrange this equation. To rearrange that, you divide both sides by m. So m and m you cancel, then you get p over m is equal to v. Okay, so we want to find v. V is momentum over mass, 12 kilogram meters per second over mass. sorry, 12 kilogram over mass is, I mean to write the mass here, mass is 4 kilogram. Okay, so 4 times 3 is 12, so 3 kg and kg cancel, meters per second. Okay. So that's the velocity, or that's the speed. So that's the momentum. And let's see. The next thing we talked about is impulse. Impulse is the product of force and time. So if you apply force on an object over some time, okay, so you're pushing an object for some time, then you're applying the impulse. Okay, so impulse is force times time. And this impulse is related to change in momentum. So how much momentum you change depends on how much force you apply and how long you apply the force. Okay, so if you push the object, if I push the object with the same force but one for longer time, okay, then I will have different momentum. So I'm going to apply same force, but this one, on this one I will apply for longer time. Okay, so same force but longer time, that means more change in momentum. Okay, so when I apply force for longer time, I get more change in momentum. So my change in momentum depends on impulse, and the relationship is called impulse momentum theorem. So this relationship is called impulse. Why is it doing that? Let me write on this. So impulse momentum theorem. It states that to change the momentum, you need force, and also you need to apply the force for some time. Okay, or in other words, the change in momentum depends on time also, not just force. So change in momentum is given by m times v. Whenever we think about change, that means final minus initial. So this is final momentum minus initial momentum. So that is equal to force times time. Force times time. Final momentum is given by mass times speed, or mass times velocity. So mass times velocity, final, and this one is initial momentum, which is mass times velocity initial is equal to force times time. Okay. So this is impulse momentum theorem, and then we will be using this theorem to do number 2. Now, how do we know that we need to use impulse momentum theorem for number 2? Sometimes people ask that question. So basically, when you solve a problem, you see what is being asked in the problem. So it is asking for the force So if it is asking for the force, think about what formula you have for the force. So you want to find the force, and the only formula you know is force is equal to m times a. Okay, that's what you know. And you also know force and momentum are, change in momentum are related by this formula. Ft is given by mv final minus mv initial. So these are the two formulas you know. We have only these two formulas so far known for finding the force. And you can find force by using either this one, the right one, or the left one. If you can use this one, that's fine, you can use this one. If this one doesn't give you force, then you need to use this one. Okay. Now in this case, actually these two are equivalent. This is actually same as this one. If I write this, so acceleration, it is the definition of acceleration. Acceleration is change in velocity over change in time. Okay, change in velocity is final velocity minus initial velocity over time. Okay, so that's final velocity minus initial velocity over time is equal to f. If I rearrange everything here, I get exactly same equation. So this theorem is the consequence of Newton's second law. Okay, impulse momentum theorem comes from, actually this is the Newton's second law. It's from Newton's second law, because see, if you take this t on the right left side, you get ft, and on right side you have mv final minus mv initial. Okay, exactly same formula, this one and this one. So we can use impulse momentum theorem in this case. But for some reason, if you cannot use this one, if you don't know a, if you don't know the formula for a, then you can just use this one. Okay, so let's use that. So what we have here, we have the speed of the paper. Initial speed of the paper is 0, it starts from rest. Final speed of the paper is 40 meters per second, and the time is 0.05, and the mass of the paper is 0.01 kilogram. So we want to find the force, and we know this formula. Force times time is mv final minus mv initial. Okay, force then would be equal to, we can write this formula as mv final. So we have mass and mass common on both sides, so you can take it out. Whenever you have two things common, you can take it outside the parenthesis and put everything else in the parenthesis. You can write this as Vf minus Vi. Okay, so that's what you can do. And this one you can take on the denominator down here. Okay, you can take this t down. You might have done this in some basic math, like if you have A times B is equal to C times D, then you can write this as, you can take this down to the denominator and write B is equal to CD over A, right? That's something you do in math. So that's what I did here. I took this T on the denominator. Okay. Now let's plug in the numbers. M is 0.01 kilogram. Final velocity is 40 meters per second. And then initial velocity is 0. That's 0. And then that's all over. T is 0.05 seconds. Okay, so that you need to do the math. So that will give you, I think, 8 newtons. Okay, just looking at that. So 40 over 5 is 8. So F is 40. F is 8 Newton. So you will need a calculator to do this kind of math if you are doing this in exam. Any question about how to do this? Will you be able to will you be able to do this if you have to do this in exam? Okay. So that's about the momentum impulse theorem. And then the next thing is we talked about lots of things, conceptual things. If you guys have any question on the conceptual things, I can answer that. So we talked about particularly this one. So if you hit on haystack versus a concrete wall, it will be more damaging in this case, hitting on the concrete wall versus the haystack. The reason for that is, in order to stop the car or the truck, you need to apply some impulse, right? So the truck is going at some speed, or it has some momentum. So the momentum of the truck is this mv. So this is the momentum, that's the momentum. So you need to go from mv to 0. Okay, so final momentum needs to be 0. Final momentum needs to be 0. So that means you need to supply some momentum to stop the car, or you need to supply some impulse to stop the car or to stop the truck. And there are two ways to supply the impulse. One is same impulse, but you can apply bigger force for shorter time, or smaller force for longer time. Okay, both gives the same impulse. If you need 1000 Newton second impulse, you can get that by applying 1000 Newton force over 1 second time, or you can get that impulse by applying 10 Newton force over 100 second time. Okay, so this is longer time, shorter, smaller force, bigger force, shorter time. Both gives 1000 Newton, but this would be less damaging because you're applying only 10 Newton force, and you get back the same force from Newton's third law. Okay, so the car exerts 10 Newton force on the wall, and the wall also exerts the same amount of force back on the truck. Okay, because this is a small force, so there is less damage. And this is what happens when you hit on the haystack, and this is what happens when you hit on the concrete wall. Okay, you get more reaction force. This is the reaction force, so you get less reaction force. So we talked about that in case of that, and we also talked about conservation of momentum. Okay, so conservation of momentum is when two objects, for example, two cars or two trucks or whatever, two things, they collide each other. The total momentum before collision is equal to total momentum after collision. Okay, so So that's after collision. So before collision they have some speed and some mass, they collide each other, and after collision they move at some other speed, okay, different speed. So there are two things that could happen here. One is after the collision they can move apart and then they just move move independently at some different speed. Okay, this can happen. Or another thing is they may get stuck with each other, okay, together like that, and they can move together after collision. So this kind of collision is called inelastic collision. So after the collision, if they get stuck, it's inelastic collision. And if they are separated after collision and move away from each other, then this is called elastic collision. So you can either have elastic collision or inelastic collision. In both cases, the total momentum remains conserved, okay, same. What that means is you have some momentum of this object, you have some momentum of this object, and the total momentum is momentum of the two objects, okay, total momentum. So the total momentum before collision would be equal to total momentum after collision, momentum of that one plus momentum of that one. So that total momentum is momentum after collision. That's the law of conservation of momentum. Okay. So let's see an example, and that will make the things more clear. Let's look at number 3. So read question number 3. We have two gliders. So glider 1 and glider 2. They are moving towards each other. One glider moves at 1 meters per second. So this one is moving at 1 meters per second. And the other one is moving at 2 meters per second. After the collision, they stick together. And then they move in some direction. We don't know which direction. It could move in this direction or to the left. So what would be the speed after the collision? Okay. So again, here we use the conservation of momentum. So the conservation of momentum tells us momentum before collision is equal to momentum after collision. So momentum before collision. Momentum before collision is momentum of first one before collision. We know the momentum is given by this formula, m times v, that's the momentum. So momentum of 1 before collision is mass of 1, let's call that m1. Speed of 1 before collision, which is 1 meters per second, okay, plus momentum of second one. Okay, we are talking about before. This is the before. I should write here total momentum. Okay, total momentum. So momentum of the second mass is mass of the second object, and mass times speed. Speed is 2 meters per second. But one thing we need to be very careful here is we also need to consider the direction here. If the object is moving to the right, we consider its velocity to be positive. If it is moving to the left, we consider its velocity to be negative. Okay? So this is very important when we do this kind of problem. So in this case, the object is moving to the left. that means this velocity would be negative, minus. We need to put minus sign there. Okay. So this is before collision. Now we need to talk about after collision. After collision, what is the total momentum? Total momentum would be mass times velocity. What is the mass here? Mass is m1 plus m2. Okay, that's the total mass. Okay, and velocity is, we don't know that, we want to find. So this is the final velocity after they get stuck. And it says that they are identical, their mass is same. So that means m1 is equal to m2, same mass. Okay, so both have the same mass, we can call that like m. So this m1 is m, same mass. We have 1 meter per second plus, or actually this minus will come in front and it becomes minus here, minus this m is m, m2 is m, same mass, 2 meters per second. Okay, so this is m and that's also m because both have the same mass m, and v final. Okay, so m times 1 is m, m times 2 is 2m. Okay, I'm not writing the unit here, I'm just writing the number and the variable. This is mass, that's 1, and I don't need to worry about the meters per second, that's the unit. Okay, so m is the variable mass, 2 is the speed, so 2m. So m is the placeholder for the mass. We don't know the mass, so I'm just using m for that. Okay, that's the placeholder. So that is equal to m plus m is 2m. Okay, again m is just the placeholder for the mass because we don't know that, Vf. So m minus 2m, what is that? What is m minus 2m? Hmm? Yeah, negative 1m. Negative 1m. I can just write m. Okay, it's like 1 minus 2 is minus 1, right? So m minus 2m is minus m. That is equal to 2m Vf. Now we have m and m on both sides. When you have m and m on both sides, you can cancel them, or sometimes people divide m on m and m on both sides. So you can cancel m and m and m. So what is left here? So we have 1 left on the left side, we have 2 left on the right side. So I want Vf, so divide both sides by 2, cancel that. So that gives me Vf is 1/2, negative 1/2, which is negative 0.5 meters per second. So that means the combined mass after the collision, they will move, they get stuck and they will move at 0.5 meters per second. Which way they move? That negative means they move to the left. Okay, so this negative sign means they move to the left direction. Okay, so then let's also look number 4. Number 4 is also impulse momentum theorem, applying impulse momentum theorem. Any question on this one before we move on to next question? Okay, so let's look at number 4. a 2 kilogram object moving at 2 meters per second is pushed by applying a force of 10 Newton for 2 seconds. So we have an object, okay, on some surface. So that's the surface, and it is moving initially at 2 meters per second. So its initial speed or initial velocity is 2 meters per second. This is 2 kilogram object, and I push this by applying force of 10 Newton, and I exert the force for 2 seconds. Okay, so for time 2 seconds I apply the force, and as a result, what will happen? So if I apply force on an object that is moving at 2 meters per second, what will happen? So an object moving at 2 meters per second, I apply force, what happens? What happens to the speed or velocity? It increases, right? Velocity increases. So then you will have greater velocity. Greater velocity means you are changing the momentum, okay? Because momentum is mv. When you increase the velocity, you increase the momentum. So you are increasing the momentum, and the change in momentum comes from impulse, okay? Because you are applying the force over some time, that means you are applying impulse. And we know that when you apply impulse, that results in change in momentum. Okay, that changes the momentum. So we saw this formula. When you apply impulse, that changes the momentum, final minus initial. This is the change in momentum because of this impulse. Okay, we can use that in this question. So let's answer number 1, A. What is the initial momentum of the object? Initial momentum. Initial momentum is, formula for momentum is that mass times, whenever you see the word initial, you use this subscript I, okay, initial. So mass of the object is 2 kilogram. Speed or velocity, initial is 2 meters per second. It's given. So that means 2 times 2 is 4 kilogram meters per second. Okay, that's the initial momentum. Part B. What is the impulse imparted to the object by the force? So we want to find the impulse. Impulse formula is force times time. Force, how much force we are applying? 10 Newton. So 10 Newton for how long? 2 seconds. That means 10 times 2 is 20 newtons second. Okay, that's the impulse. What is the final momentum of the object? So to find the final momentum, you can use this formula. Final momentum is m times v final. But we don't have this final velocity, so we cannot use this. So we need to use our impulse momentum theorem. Okay, our impulse momentum theorem is that force times time is mv final minus mv initial. So use this formula. So force, like we already found this one. So this is 20. Okay, impulse. That's the impulse F times t. We already found this initial momentum, which is that 4 kilogram meter per second. and then we want to find this final momentum. This is the final momentum. Okay, so we want to find MVF, final momentum. So how do we get that? So you can take this thing to the left. So MVF would be 20 Newton second. When you take this to the left, it becomes plus, okay, 4. This is also Newton second. So Newton second and kg meter second are both same thing. So you can replace that by Newton second. Or if you like, you can write both. You can write this one and this one, just kg meter per second, same thing. So that's the final momentum. So 20 plus 4 is 24 Newton second, or often we write the unit of momentum as kilogram meter per second. Okay, so that's the final momentum. Okay. And then the next thing we discussed is about work. Work is given by force times distance. If you apply force on an object, and if the object is displaced by some distance d, then the force is doing the work. Okay, the force does the work when it displaces the object. If it doesn't displace the object, then the force doesn't do any work. If you push a wall by applying 1000 Newton force, and if the wall doesn't move, then there's no work. Okay, work is 0. So in order for you to do the work, you need to displace the object by applying the force. So that's the work, and we introduced two things after the work. So we talked about energy. There are two types of energies. One is mechanical energy. There are many types of energies, but we are mostly interested in mechanical energy. So we are interested in kinetic energy and potential energy. So these energies are called mechanical energies, or mechanical energy. So potential energy is due to the configuration of object. If you have an object on the ground level, if you lift the object to some height h, then this object will now have some potential energy. Okay, it's because of the configuration of that object. So potential energy is denoted by PE. It is given by mass times acceleration due to gravity times height. Okay, the higher the object, more the potential energy it has. Here g is, you can write g as 10 meter per second squared. Okay, that's the acceleration due to gravity, which is always constant. And then kinetic energy is the energy possessed by any object that is in motion. Okay, an object moving at some speed v has the kinetic energy of 1/2 mass times velocity squared, or speed squared. Okay, that's the kinetic energy. Now, what is the relationship between work and energy, or work and kinetic energy? The relationship is given by a theorem called work energy theorem, according to which if you do a work on an object, so you do the work on an object, the work has to go somewhere, okay, because work means you are putting some energy. It has to go somewhere. Where it goes is, it is utilized to increase the kinetic energy of this object. So this is used to increase the kinetic energy of the object. It could also decrease, okay, I should just say change. It could either increase or decrease. Okay. For example, if the object is moving with some kinetic energy or speed, if I work, I can stop this. I can change the speed of the object. I can decrease the speed or decrease the kinetic energy. If it is moving in this way, if I push it, I did some work on that object, and my work is used to increase its kinetic energy. So I can either increase or decrease the kinetic energy depending on which way I do the work. Okay. So that means the work done on an object is equal to change in kinetic energy. So mathematically, how do we write that? Work is W. Change in kinetic energy is, whenever you see the word change, the change means final minus initial. Okay, that's always true. So final kinetic energy minus initial kinetic energy. Okay, that's called work energy theorem. So let's look at number 7. We haven't done 5 and 6. We'll go back to number 5 and 6 in a while, but let's first see number 7. So it is asking how much work is needed to change the speed of 2 kilogram of object from 10 meters per second to 20 meters per second. Okay, you have an object moving at 10 meters per second, and you want to change it to 20 meters per second. That means you want to increase the kinetic energy. It has some kinetic energy. Anything that has speed has kinetic energy. Okay, so it has some kinetic energy, which is given by 1/2 mass times speed squared. Now you want to increase the kinetic energy from that to some other kinetic energy, and for that we need to do some work. Okay, we need to push it, do some work. So it's asking how much work I need to do to increase the kinetic energy. So work I need to do is given by final kinetic energy. Final kinetic energy is 1/2 mass times final velocity squared. Initial kinetic energy is 1/2 mass times initial velocity squared. Okay, so that will give us the work. So that is equal to anything that is same, I can put it outside the parenthesis. So half is common to both. I can take it and put it outside the parenthesis. M is also common, so I can put it here, and then put everything inside the parenthesis. That's something we do in math to simplify the things. Okay, so that simplifies the thing. So that is equal to 1/2. Now we have the mass of the object is 2 kilogram. So write 2 kilogram. the final speed of the object is 20 meters per second, and we have square there, so we need to square that, minus initial speed is 10 meters per second, square that. So now we need to do the math. So you see here, this 2 and this 1/2 and 2, they cancel, this one cancel. So we have 20 squared is 20 times 20 is 400, 10 squared, 10 times 10 is 100. Okay, 400 minus 300, 400 minus 100 is 300. So we got 300. And what is the unit of work? Work is kind of energy. Work and energy are same thing. So what's the unit? You guys remember? Unit of work? Let me give you option. Is it Newton? Is it joules? It is watt? Is it Pascal? So I'm giving you 4 options. Newton, joules, watt, Pascal. Which one? What is the unit? Which quantity has the unit of Newton? Force. Yeah. So this is not right. How about this one? Joules. Which quantity has the unit of joules? Energy, right? And energy and work are same kind of thing. Watt is the unit for power. Pascal is the power unit for pressure. Okay, so this is joules. Now let's go back to number 5. 5 is pretty straightforward because it's just using the potential energy formula. Any question on this one before we move on to number 5? Any question about the math? Okay. So let's look at number 5. A 2 kilogram mass that weighs 20 Newton has 40 joules of potential energy relative to the ground. What is its height? So we are given the potential energy PE. We know the formula for PE. PE is mgh. And we want to find height. Okay, this is what we want to find. So how do we write this in terms of height? I want to rearrange this and write in terms of h. You guys tell me like what would be the height. So how do I write h? H would be equal to what? No. What I'm saying is I just want to rearrange this formula and write in terms of h. Just rearrange this formula. Yeah, PE over mg. That's right. So potential energy is given. It is 40 joules. mass is given 2 kilogram, and g is the acceleration due to gravity, and its value is 10 meters per second squared. Okay, that's what we use always, 10 meters per second squared, and then you do the math. Okay, so 40, 2 times 10 is 20, 40 over 20 is 2, h is 2 meters. And let's go to number 6. .5 kilogram object has the kinetic energy of 20 joules. At what speed the object must be moving? So it gives us the kinetic energy. So kinetic energy, and we know the formula. So kinetic energy is 1/2 mv squared. Now we want to write this in terms of v. That's what we want to find. So we need to do a little bit of rearranging here. So let's first get rid of this 2. To get rid of 2, multiply both sides by 2 and 2. So that 2 and 2 will cancel. And then we want to get rid of this m. So divide both sides by m. Divide by m. So we have 2 times ke over m is equal to this m and m cancel. So we are left with v squared. And we need v, not v squared. So how do we get v from v squared? You take the square root, okay? 2 ke over m. So that gives us v. And the rest is just plug in the numbers. So 2 times kinetic energy is 20 joules. Mass is 0.5. So if you guys have calculator, do the calculation and tell me the number. Is that about 14, maybe 14 point something?
I got 4 squared 5 or 8.9.
You got 8.9? 8.9, okay, meters per second. Okay. So that's the speed at which the object is moving. That has the kinetic energy of 20 joules. Also, let's look at number 8. You pushed an object using 20 Newton force. As a result, the object is displaced by 2 meters. How much work have you done on the object? So this is also work energy theorem, because it's no, not work energy theorem, sorry. This doesn't need work energy theorem, it's just work. So you just need to find the work. Okay, so work. It's not asking for the energy, so you don't need to worry about the energy, just the work. Work is, the basic formula for work is force times distance. Force is given, distance is given. So the calculation is pretty straightforward. Just multiply 20 and 2. that will be the work. 40 unit of work is joules. Now the second part is asking for the power. Okay, so power is basically how fast you can do a work. Okay, faster you do the work, more power you have. In other words, power is defined as rate of doing a work. Okay. And it is work over time. Okay, work over time, how fast you do the work, or in 1 second how much work you can do. That's different ways of stating the same thing. So work, we did 40 joules of work, and in what time we did that work? We did that work in 2 seconds. So 40 over 2 is 20 joules per second, and sometimes instead of writing joules per second, we just write watt. Okay, the unit of power is watt. So that's 8. And then the last one, number 9. Number 9 is from chapter 4. So on chapter 4, we did only one kind of numerical question, numerical problem, that is to find the gravitational force. So if you have two objects that are at distance d from each other, so the first object is m1, mass m1, second object is m2, mass m2, then the force between the two objects is given by this formula. F is g times m1 times m2 over square of distance. So this gives us the force between two objects. Now the value of g is always constant. It's called universal gravitational constant. It's 6.67 times 10 to negative 11 Newton meter squared per kilogram squared. So in the question, we are given this force. This is given, mass is given, this is known, and we need to find d. Okay, d is unknown. So we want to write this equation in terms of d to find d. So how do we do that? So you can take this d up here and then f down here, okay, because we want to write this in terms of d. Or sometimes people, what they do is, in math, if you want to move the things, you do the division or multiplication. So divide both sides by, multiply both sides by d squared. Okay, d squared, and then you cancel this d and d, and then that's how you get d squared on this side. Now if you want to get rid of f, divide both sides by f. Okay, so that's what you do. You cancel that, and now you have d squared. So d squared is g m1 m2 over f, and then you want to get d, okay, not d squared. So you want to get d. To get d, you want to take square root on both sides. So square root on both sides. Square root and square will cancel, so you'll only have d. And on the right, you have square root g m1 m2 over force. So now let's find d. So square root, plug in the values. G is 6.67 times 10 to negative 11 Newton meter squared per kilogram squared. That's the value of G. The value of mass M1 is 6,000. The value of mass M2 is 10,000. And force is 0.02 Newton. Now you will need a calculator to do this one. Okay, I cannot do this by hand. So let's do that with a calculator. And you need a scientific calculator. You cannot do with the ordinary calculator. Yeah.
Is this one that will?
Yes.
Okay. And my problem is I don't know how to.
Okay.
I've never shown how to press
So you start with square root. Where is your square root? So that's square root. So whenever you have these green ones or something under the button, you need to press this one first, okay, to get that function. So that, and this will give you the square root. Okay, and now you punch the first number 6.67 times. So let's see it now. Where is 10 to? Okay, so that's that. So if you have this one, then you don't have to do that times. So you can delete that. Oh, it's just clear. So I should have done that. Delete. Okay. Different calculators have different kinds of, yeah.
This one?
Yeah. And then press that one. That's times, and now negative 11. So negative is not that negative. Oh yeah, this negative. So you have two types of negative here. One is this one. This one is for the power. Okay, this is what you need to use.
Okay.
And if you want to subtract something, then you will use this negative sign. Okay, and then yeah, put that in parentheses. Let's see. I think if you put that in parentheses, then that square root will be only just for that thing. But we want to do the square root for everything. That means let's not put that parentheses. So let's delete that. So just do the times 6,000.
Parentheses?
No, you don't need parentheses, just 6,000. And then times 10,000. And now put the parentheses. And then let's see. No, not you don't need parentheses because we want to cover everything with the square root. So now divide that by 0.02. Okay, and then now put the parentheses and then enter. So that would be the distance. So did you guys get the answer? Not yet? You don't have calculator? Okay.
And how far do we go out?
You just need 2 to 3 digits after the decimal. So you can round that off to 0.45. So 0.45, is that what you got? Okay, 0.45 meter. Okay, so I think that's all for this lecture. Do you guys want to just keep reviewing the things in the next lecture? So you want me to introduce new chapter? What do you want to do? Should we just do the review like this, or should we start new chapter next week? Don't know?
I don't know this reference, that's
Okay. Okay, we'll decide later then. I will announce it on Blackboard then.
Okay, and the 0.45, we divide that by 0.02.
No, we already did that. So that's everything, yeah.
0.45 is the answer.
Yeah, so 0.45 meter. So I've focused mostly on the numerical questions here, but if you guys have any conceptual questions, you guys can ask me conceptual questions also, okay? We don't need to just focus on that, because some people were having trouble with this numerical thing. That's why I'm focusing mostly on this.